Hello again, Year 9. Here we are, another new week, and it's a new topic. The electricity in the home is a very short one. This is also a short topic, so hopefully we'll get this completed before the end of the summer term. We're moving on to crude oils and fuels, and this is crude as in not yet separated and sorted, as opposed to any other meanings of the word crude. And you've got a check-up on the first slide here, which is about fossil fuels. I've been really kind. I've given you the first letter of each of the three types. Two other questions as well. Obviously, you know that while you do this question, you can pause the video. And here are your answers. Oh, sorry, I clicked to add title. That looks a bit weird, doesn't it? Okay. So you've got your three types of fossil fuel: gas, coal, oil. Doesn't matter the order. Are they renewable? No, once they have been used, they are gone for good. It doesn't mean that the chemicals contained in them are gone for good. They will have, it's a chemical reaction, so they will have changed. They'll be in a different form, but you will not be able to get the fossil fuels back again. And they are made, or they were made, sorry, a long time ago. Things died, mixtures of animals and plants, not just animals. They decayed, they're put under pressure, usually under the sea, and they liquefied or became vaporized, and that is how you made the fossil fuels. And it's the fact that it takes millions of years to make them, which also contributes to them not being renewable. Now we have got three objectives this week. One is to know what crude oil is made of, another one is to know what is an alkane, and another one is how to show the chemical and the displayed formulae for alkanes and name them. I'm also going to give you an opportunity to go further and learn some other groups as well, but that will depend on how well you are managing the work. So, straightforward. Hydrocarbons. The clue is in the name, really. They're made from hydrogen and carbon. Fairly straightforward. Now, hydrogen is an atom which is able to make one bond only, so it can only join to one thing, a little bit like having one arm. Carbon, on the other hand, because of its electron configuration, is able to make 4 bonds. So that means that hydrogens and carbons can join together, and they can either make chains if they're in a long line of them, or they can make ring structures, and they can make very long, very complicated molecules. But hydrocarbons actually only have hydrogen and carbon in them. And they include fuel that is used to power cars, that's petrol and diesel, fuel that's used to heat homes as oil, and many of them are contained in a mixture called crude oil, linking back to the fossil fuels we talked about at the start. And a mixture, remember, has got lots of different things in the same space, but they are not chemically bonded. Think about sugar and salt in one container. You'll be able to taste both of them. You could separate them, and they're not actually undergoing a reaction. They're just in the same space. Now, alkanes are the main group of hydrocarbons in crude oil, and the start of it, the prefix, tells you how many carbon atoms are there. So it's got a meth, then it's got 1 carbon atom, and eth, it's got 2, prop, it's got 3, bute, it's got 4. And they all have an ane on the end, so I've started the name here for you to finish it, and the number of carbon atoms goes next to it. And this is a table that you will need to copy and complete. You want to leave some space here for a third column because you can do something else as well in a moment. So pause the video while you do that. Now this is the slightly tricky bit, but pay careful attention, it won't be too tricky. All you need to remember is that each single line here is a single bond. And you already know that carbon can make 4 bonds and hydrogen can make 1. So hydrogen can only join to one thing, carbon can join to 4. So here we've got a molecule of methane. It's got 1 carbon in it in the middle here, and as it's able to make 4 bonds, it's joined onto 4 lots of hydrogen. That gives you the formula CH4. You could write H4C. That would also be chemically correct. Just conventionally, the C goes first. and that is called a displayed formula. It's quite straightforward. It's a little bit like a squash spider, really. You've got 3 other alkanes in your table. You had ethane, propane and butane. So if you could please draw the displayed formulas for those on your table, that would be great. Now there is a general rule or general formula. You'll have used these statements in maths where you find the nth term of a sequence. It's exactly the same idea. So if there are n atoms of carbon, there'll be 2n plus 2 atoms of hydrogen, which sounds really awkward, but actually here we go. Here's your carbon, that's the 2 for 2n, that's n is 1, so that's 2, and there's plus 2 more. And that works because they can form 4 bonds. When you add the next carbon, you would end up with 2 carbons together and hydrogens around the edge. You know that already. There we go. So, when you have alkanes, they have a number of properties. They have a size, whether they're long or short chain, what their boiling point is, their volatility, how easily it becomes a gas. Now you may well have been at a petrol station and seen signs warning you that there are things around that are flammable, and flammable liquids are ones that are volatile and can quickly change from being a liquid to being a gas, which will then catch alight easily. Viscosity, how easy it flows. Okay. And flammability, how easily it burns. Flammability is related to volatility. And the last 4 here, boiling point, volatility, viscosity, flammability, depend on how long the molecule is. And here comes some data, because I know you love data. So we have got the names of lots of alkanes. Some of them you've already had. Butane you've already had. Oh, pentane you haven't, but hey, guess what? I bet you know what pent means from your maths. Hexane, you haven't had that, but hey, you know what hex means from maths. And hept and non and dec. The last 3, not ant and dec, undecane, dodecane, hexadecane, you might need to look at on the internet to find out. I believe this service called Google is quite good for that. All you need to find out to complete this table is the number of carbon atoms that goes with each of these alkanes. If I've been kind, you might find that they're in some sort of order. You've already got information on boiling points. I'm not asking you to look that up because I'm just too kind. When you have got the number of carbon atoms and you've got the next boiling point next to it, I want you to describe the relationship. This will be a general statement. So it could be as the number of carbon atoms, and it'll be either increases, decreases, goes up, doubles. You have to have a look at it to see what it's going to be. I'm not telling you. The boiling point, and again, you can add the information in there for yourselves. Hopefully, this is so far so good, quite straightforward, a little bit weird and wonderful with these very similar names, but as these numbers, these words at the beginning here are prefixes that you quite often have used in maths, shouldn't be too tricky for you. And the last thing now is a little bit of fun coming up. Now, I want to make sure that you really know the compound and the formula and the displayed formula. So to practice this, we're going to make a set of cards. You can use paper, you can use a real card, you can use the back of a cereal packet. You need to have make the cards the same size, and for each compound you're going to have 3 cards. One is just going to show the name written as a word. The next card is going to show the chemical formula. So that will be C's and H's. The last one will show the displayed formula, which is how you draw it out to show the carbons and hydrogens. When you've made the set of cards for all the alkanes you've got on your chart, you're going to mix them up, place them on the table upside down. Turn them over, put them into the sets where you have the name, the formula and the display formula that belong together. How quickly can you match them up? Mix them up again, put them upside down again, repeat it, improve your score. Now, I am being very kind to you because I'm a lovely person. I have given you a link to a set of cards which you can just take out the alkanes that we know if you like. However, on the linked set of cards, I have also provided information about esters, alcohols and acids. Now, they don't just have carbon and hydrogen, but they're very closely related. I'm sure you'll be able to spot the patterns quite easily. This also lets you check your answers, make sure that you have got your displayed formulae correct, because there is an answer sheet at the end to help you match them up if you get confused. So hopefully you've got everything you need from me here. I haven't given you a quiz this week. There will be another one though next week. There is information about this on BBC Bitesize if you need some more help, or of course you can put up a message and posts on Teams, or you can email me. Have a good week. See some of you at school. Take care, Year 9. Bye for now.